Good day, students, and welcome to the next video for Digital Systems 1. In this video, we're dealing with Study Unit 2 and specifically Boolean conversion. So Boolean or binary numbers are basically numbers represented by 1 or 0. And they're used by digital systems or computers so that the computers can understand the decimal numbers they're working with. And they can also use hexadecimal, but we will come to that later on. And here is a simple table representing the number decimal value of 0 to 4. And here I have filled in this, what we call the truth table, and we will work extensively with these. Here you see 0, 0, 1 is 1. The binary number 1, 0 is equal to 2, 1, 1 is equal to 3, and 1, 0, 0 is equal to 4. Now, an easy method that I found for setting up a truth table of binary numbers and decimal numbers is you set up a table like this. You write on a piece of paper decimal values 0 till whatever you want, in this case 0 to 7, and then you start with the least significant bit and you write 0, 1, 0, 1, 0, 1, 0, 1 until you reach the end of this column. In the next column, you double the number of zeros and ones. So you have 0, 0, 1, 1, 0, 0, 1, 1. And in the next column, you double it again. So you have 4 zeros, 0, 0, 0, 1, 1, 1. And in the next column, you double it again. So you have 8 zeros and then 8 ones, as not shown here. And in the next column, if you want to go that far, you have 16 zeros and then 16 ones. So what it gives then, you can easily write up a table like this without having to memorize any of this. So as you can see here, 0 is equal to 0, 1, 1, 0 is equal to 6, and 1, 1, 1 is equal to 7. So once again, easy way of setting up a binary number to decimal truth table is on the least significant bits. You write 0, 1, 0, 1, 0, 1, 0, 1, and then you double again 0, 0, 1, 1, 0, 0, 1, 1, and then again 4 zeros, 4 ones, with the corresponding decimal values on the right side. Now, in the test, you're welcome to do this and just you use it to check your answers that you get later on. Also, a note on a convention of numbers. If a number is written like this, 0.1011, and it's got this 10 at the bottom, that means that this is a decimal number. So this is a number that we use, that you're used to using in normal mathematics. If the same number has this little subscript here and it's a 2, this means that it's a binary number. And the binary arithmetic applies to it. And if it's got an 8, it means octal, and if it's 16, it's hexadecimal. So whenever you see a number on a test or an assignment or wherever at work, pay close attention if it's got a subscript like this. If it says a 2 there, then this number is a binary number. If it says a 10, then this number is a decimal number, as you will probably no doubt see in the study guide. And again, when we have a binary number 1, 0, 1, 1, 0, 0, 1, 1, 1, the furthest most number here is the most significant bit, and the furthermost right is the least significant bit. Now we called that because the most significant bit is the number that carries the most weight. When you remember the table, the number on the far left hand side, that has the most weight. It counts for more, like this. It's the same as if you have a decimal number. Let's say you have a decimal number of 121. The first number that signifies the 100 has a bigger weight than, let's say, the 20 or the 1. So that is where most significant bit and least significant bit comes from. Now, if you have a fractional number, binary number, the first number after the fraction, the comma, is the most significant bit, and as you go further right is the least significant bit. And it's the exact same reason. That first number is worth more than all the others. So that if it's, let's say, 0.1, is more than 0.01, for instance. The numeric value is more. And just MSB, most significant bit, and LSB, least significant bit. Now we get into converting a binary number to a decimal number. So first off, we start by writing out the binary number that we want to convert. So we write 1, 1, 0, 1, 0, 1, whatever one you want. Then we use the weighting method to convert the decimal writing. So we write 2 to the power of whatever position is there above them. So we call this the power of 2 method. So if we have 1, 1, 0, 1, 1, 0, we write 2 to the power of 0 for the first position, 2 to the power of 1, 2 to the power of 2, 3, 4, 5, and so on if you have a bigger number. So now what we do is we multiply the bottom row with the top row, as shown here. So you have your binary number, and then you multiply that by that, 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 and you add it all together. So this then becomes 1 times 2 to the power of 5, which is that one there, plus 1 times 2 to the power of 4, which is that bit there, 0 times 2 to the power of 3, which is that bit over there, 1 times 2 to the power of 2, which is that bit over there, 0 times 2 to the power of 1, which is that bit over there, and adding 1 times 2 to the power of 0. Now, to start off, you obviously use your calculator, but as you get better with the power of 2, you will be able to do this pretty quickly. So then 1 times 2 to the power of 5 is 32, 1 times the power of 2 to the 4 is 16, and you have 0, 4, 0, and then 1 times 2 to the power of 0 is 1. So you're adding all this up, the number is 53. So 1, 1, 0, 1, 0, 1 is equal to the number of 53. So let's try a different number, 1, 0, 1, 0, 1, 0, just to see what we get. So follow a number, write the power of 2's above it, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to 4, 5. Now, remember, if there's another binary digit here, we will be 2 to the power of 6. Okay, so we have that one corresponding to that one corresponding to this one, and that one, and that one. And then we add it all together, and the answer is 42. Now, if you want to check yourself easily, you can just go online and Google binary to decimal conversion, and they will come up with these online calculators. You write in the binary number or the decimal number, and you just check your work while you're doing this at home. Now, we want to convert a binary with a comma or a fractional binary number. So we follow the exact same method. We write down the binary number 0, 0, 1, 0, 1, and then we write the powers of 2 above it. So 2 to the power 0, which is the state for that one. We have 2 to the power of minus 1 because we're going in the other direction of the fraction. 0, 2, and then for that one is 2 to the minus 2, 2 to the minus 3, and as we go on, it will be 2 to the minus 4, 2 to the minus 5, and so on and so forth. And then once again, we multiply it out. So 0 times 2 to the power of 0, 2 to the power of 0 is equals to 1, is 0. 1 times 2 to the power of minus 1. Now, 2 to the power of minus 1 is the same as 1 over 2. And so 1 divided by 2 is 0.5. And that is the same for, that is basically saying 0 divided by 2 to the power of 2. And that is 0. And that is the same as 1 multiplied by 2 minus 3, and 2 to the power minus 3 is equals to 1 over 8. So 1 divided by 8 is 0.125. And adding them all together, you have the number of 0.625. Now, most calculators would be able to let you do this as is, and you will have no problem punching it in. And let's do another example, converting the following binary number to a decimal number: 110 and then 0,011. So we follow our procedure. We write down the number like this, write down the power of 2's. Whenever we hit the comma marker, the power becomes to the minus. So as you can see, we wrote everything down here with the minus powers, and we multiply it out and we get our answer, which is 6.375. Now at home, pick any binary numbers and just convert it, and you will get pretty good at this as you practice. Now, converting decimal to binary, going the other way around. The method is slightly different. We divide by 2 until we cannot anymore. And I'll explain this. So let's have an example. Let's convert number 21 to binary. So here we have 21 divided by 2 is equals to 10. And there's a remainder of 1. Of course, 21 divided by 2 is 2 with a remainder of 1. So there's 1 left, which is, if it was 20, it would have just been 10, but now it's 21, so there's a remainder. And that first remainder is our least significant bit. So there's a further rightmost bit. Then we keep on dividing by 2. 10 divided by 2 is 5, and our remainder is 0. And then we take the 5. 5 divided by 2 is 2, with a remainder 1. Now we have 2 divided by 2 is equals to 1, the remainder of 0. And now we have to divide 1 divided by 2, which is equals to 0, with a remainder of 1. We have to go until we are left with a 0 here. So we divide until we're left with 0. And this last bit here is our most significant bit. So the first division results in our least significant bit, and the last division results in our most significant bit. So this means 21 is represented as 1010 in binary. So let's do another one. Let's do 52 as in the study guide. 52 divided by 2, 26, remainder 0. So that 0 is our least significant bit. And then 26 divided by 2 is 13, remainder 0. 13 divided by 2 is 6, remainder 1. 6 divided by 2 is 3, remainder 0. 3 divided by 2 is equal to 1, with a remainder of 1. And now 1 divided by 2 is 0, remainder 1. So that 110100 is our number from most significant bit to least significant bit. And we stopped when we have a 0 here. So lastly, let's convert a fraction into binary. So you have a fractional number, fractional decimal number. How do you convert that into binary? So here, in the normal decimal number, we multiply by 2, but here we divide it by 2, but here we will multiply by 2. And then if the number is more than 1, we write down 1, and then take the remainder and then multiply by that 2 again until we have a whole number as in 1. So let's show you an example. Convert 0.625 to binary. So we take 0.625, we multiply by 2, the answer is 1.25. So that means we have a 1 here, which is, we take it as our carry, and that is our most significant bit. So we take then the 0.25 here, and then multiply that by 2, which is 0.5. Now that's a 0, so we carry a 0. And then 0.5 we take here, multiply by 2, we have 1, and then when we get 1 we stop, but we write down a carry 1. So 0.625 is 0.101 in binary. So just to recap, if we multiply by 2 and you have a 1 here, that means you have a carry of 1. Then you take the remainder 0.25, and we multiply that by 2 in the next step. And then we check for a carry, so 0, 0, and then we carry on in that process until we get to 1. The previous time we stopped at 0, here we stop at 1. So let us convert the number which we converted from binary to decimal. Now let's convert it back to binary. So first let us split up the number 6 and 0.375. So let's split up the whole number and the fractional number. And we do them separately just to simplify things. So here we have the whole number 6. We follow our process until we have a 0. And now we have a 1, 1, 0 as our whole number, binary number. And then we have 0.375. And as our process, we multiply by 2, which is 7.5. And then it's obviously a 0 carry. Multiply that by 2, you have 1.5, which is a carry of 1. And then multiply 0.5 times 2, which gives you 1, which means we stop. And that is a carry of 1. So here we add the two numbers together, which in the previous answer had 1, 1, 0 for the whole number, and then the 0, 1, 1 for the fractional number. Now, just very important note, you will get confused doing these conversions, because when we convert the decimal number to binary, we write the least significant bit first until we get to the most significant bit at the end. But if we convert a fraction, the first number we write is the most significant bit, and the last one is the least significant bit. Just look again at what we did in the previous equations. When we have the whole number, the first number we receive or calculate is the least significant bit, and the last number is the most significant bit. And then conversely, when we write a fractional number, the first number we calculate is the most significant bit, and the last number, when we get to 1, is the least significant bit. Very important to note, because it will change your equation significantly if you don't get this right. Okay, that is the video. If you have any questions, don't hesitate to email me, and I will get back to you. Good luck.